Hey everybody, welcome back. We have successfully completed the chapter on polynomials, so we're ready to move on in our algebra book to the next chapter, which is actually about graphing quadratic equations. But before we get to that, our book has a little warm-up just to make sure that you still remember how to do some of the basics of graphing. So today, for my assignment for my algebra class, I've just got kind of a review thing of, do you remember how to graph linear functions and then how to evaluate an expression when they give you a number to plug in? So before we get to the second part, just a quick review. How do we graph a linear function? Because some of the concepts that you use to graph a linear function will carry over to graphing the quadratic equations or the quadratic functions. Not all of them are the same. But for example, if I gave you, or the book gave you an equation like, I don't know, let's say this one, y equals 1/2 x minus 3. I hope we remember how you can graph this in about 15 seconds, right? In case you forgot, it's been too long. We've been at home. We've forgotten everything. This was way back in the first semester. As long as the equation is in slope-intercept form, right? Y equals something x plus something or minus something. You can always look here at the end. I like to look at the end first. The end of the equation is the y-intercept. The end of the equation is the beginning of where I make my graph. So in this case, the y-intercept is -3 because it has the minus sign in front of it. That's a clue that I'm going to start on the y-axis because it is the y-intercept, right? This is the y-axis. This is the x-axis over here. So I'm going to start on the y-intercept, and let me switch to orange since this equation's in orange. My first dot, my first point, is going to be at -3, right on the y-axis. Kind of blends together with the black marker there, but that's going to be my first point. And then once you get that on there, you look at the slope, right? The slope is always the coefficient on the letter x. That's another way of saying the slope is always the number that the x is being multiplied by, right? The slope and the letter x are always connected with multiplying. So in this case, the slope is 1/2, right? Remember, slope is rise over run. So that's another way of saying we're going to rise up 1, we're going to run over to the right 2. So we're going to go up 1, over 2. When I say over, that's to the right. And then I like to do it one more time. Up 1, over 2. Now we could keep doing this forever and ever. We could keep going up 1, over 2 as long as we wanted. But really, all you need is about 3 dots to make your line. Once you have 3 points, your line is complete. Right? That is the fast way to graph linear equations. Okay? Now, just as a quick aside, I'm not going to do this on any other question just because it's so time-consuming. But if you would rather go kind of the alternate route, which I think is a little bit longer, but this would be a way to double-check your answer if you were unsure of yourself. On any of these questions, you could make an x and y table, right? You could pick any numbers you wanted. I'm just going to pick easy numbers like 0, 1, and 2. And you can plug them in for the x and then work it out, right? If I put 0 in here, 1/2 times 0 is 0. And so my statement would be 0 minus 3. Okay, 0 minus 3 is -3. You can see that's one of the points on my line. If I put 1 in here, 1/2 times 1 is 1/2. So 1/2 minus 3 would be -2.5. So the point 1, -2.5 is like right here, which is basically on my line. And then 2, if I put 2 in there and substituted that in, 1/2 times 2 is 1. 1 minus 3 is -2. You can see 2 -2 is this point right here. And so if you would rather do one of those x and y tables because you really enjoy doing those, an input-output table, a function table, whatever you want to call it, you could do it like that. But if I'm just being straight up honest with people, that's kind of the longer way to do it, right? Let's do a different one just to make sure you haven't forgotten any of this. Let's start off with, let's try this one, right? Whoa, I don't have an x in there. -2/3 x plus 5. You got to have an x in there. So in my example here in purple, the y-intercept is the number at the end, the number that's all by itself that doesn't have the x connected to it. In this case, it's 5, so I'm going to start way up here at 5. +5. Now this slope is -2/3. You can see right here the slope is -2/3. When the slope is negative, instead of going up, you're going to go down. Like on this orange one, we went up 1 and 2 to the right. On this one, we're going to go down 2 We're still going to go to the right, though. I never go to the left. Go down 2, 3 to the right, down 2, 1, 2, 3. And I can do it one more time, down 2, over 1, 2, 3. I'm almost off my graph. And so that line would go like that. Okay. Hopefully this is starting to come back to your memory now. Let's do one more. I'll give my green marker one more try. It didn't work last time I used it. Oh, there we go. Just need a little bit of a rest. Okay. In green, I have y equals 2x minus 1. So on this example, the y-intercept is the -1 at the end. So I'm going to start at -1 right there. And then the slope on this one is 2. It's not a fraction, right? It's always easy when it's a fraction like here and here to say, oh, I'm going to go up 1 over 2, or I'm going to go down 2 over 3. When it's only a single number, you can just make it over 1, right? So in this example, I'm going to go up 2, 1 to the right. I'm going to do it one more time, up 2 more, 1 to the right, and then you can connect the 3 dots, right? So that's how you'll graph any type of linear equation. You know what? Let me do one more. I can think of one more example they may throw at you that I don't want anyone to get stuck with. What if they do this? Y equals -3/4 x, and they just stop right there, right? If they don't give you a y-intercept, right, there is no +5 at the end, or -3 or -1. If it's just, it stops after the letter x, that's the same thing as having like a y-intercept of 0. That means it goes through the origin. Right? So in this case, we're going to start at the origin. Since they didn't give us a y-intercept, it's 0. And then the slope is still the coefficient on the x. The slope is still -3/4. So I'm going to go down 3, 1, 2, 3. I'm going to go 4 to the right, 1, 2, 3, 4. I'm going to go way down here. If I had room, I could kind of freehand down 3 over 4 more, maybe something like that. When you do this on the computer, they'll have the graph already kind of set up for you, so you won't have to worry about freehanding it like I did there. Okay, that is how you graph linear equations. You'll notice all of these equations are just x to the first power, right, on every single one. Just x to the first, x to the first, x to the first, x to the first. The chapter we're getting ready to start actually will have squared. Everything will be x squared or w squared, or it'll just be x squared. But the variable will be squared to the second degree. Okay, one more part, and then we're done. There is one more little warm-up section they wanted us to try. They want us to get a little bit of practice evaluating expressions. So an expression here is different than what we had on the last ones, because on the other ones we had equals y or equals whatever. These are just expressions. There is no equal sign. And it's going to tell you what to substitute in for the letter x. So they're going to give us a statement, letter A, B, and C here. I have 3 different expressions written. And they're going to tell us to plug in or substitute -3 in the spot of x everywhere you see the letter x. All right, so for this first one, anywhere I see the letter x, I'm going to put -3 right there. Okay, not too bad. So on the first one, I'm going to do -3 x squared. I'm just going to put a -3 right there. Okay, 5x. I'm going to do brackets on this one. You could do parentheses, though. I just kind of like to do brackets sometimes when I get too many parentheses. And so I put -3 in the spot where I see an x. Every single spot where there's an x, I just substitute in -3, and then you can just work it out, right? Let's do the exponents first. -3 squared is the same thing as -3 times -3. That's 9, positive 9. And then in the parentheses, 5 times -3, that's -15. And then -6. And now we have adding and subtracting, so you just go left to right. 9 plus -15, that's -6. So I have -6 minus 6 more. And that, I believe, is -12. Okay. So this is pretty basic. This is more like a 7th grade topic, or maybe an early 8th grade regular math topic. On letter B here, I do the same thing. X is still -3. So if I put -3 in here, it's going to be 5 times -3 squared minus 7. Whenever you substitute in a negative, I always like to put it in parentheses just so I don't forget how it applies here with the exponents. Remember, in your order of operations, right? Parentheses, exponents, multiply and divide, add and subtract. Parentheses, we really don't have anything to solve in parentheses, but we do have exponents. So exponents come before multiplying. Don't you dare do this and get negative 15 and then do negative 15 squared. No, 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 no. Exponents come higher before multiplying and dividing. So we need to do negative 3 squared. Negative 3 times negative 3 is 9. And so now we have 9 times 5, or 5 times 9, either way, minus 7. So 5 times 9, that's 45. 45 minus 7. I think that's 38. You could double check that if you wanted to, but I'm pretty sure I have it. And we'll do one more. And I think since the green marker's working, I'll go with that one again. Still using this, right? X equals negative 3. So I'm going to rewrite this one. Anytime I see the letter X, I'm going to put negative 3 in there. Okay. This one's a little tricky because we have all these negative signs and subtracting signs, but don't let that bother you. All right, remember your process over here. Parentheses, I mean, I have parentheses, but there's nothing to really solve in the parentheses, so don't worry about that. Exponents, I definitely have exponents right here. I have negative 3 squared. Negative 3 squared is negative 3 times negative 3. That's 9. I'm just going to copy down everything else so I don't lose it. There we go. And now I'm going to multiply and divide from left to right. So I see some multiplying right here. Negative 3 times 9. That's negative 27. I also see multiplying right here, right? Negative 4 and the negative 3. These are actually being multiplied. There's no symbol in there, but I could put it in there if I wanted to. Since this has a subtracting in front of it, I'm almost going to treat this like negative 4 times negative 3 and call that positive 12. And then I have plus 10 at the end. And now I'm done with all the multiplying and dividing. Now I can add and subtract from left to right. And I'm going to back up my phone here because I'm running out of space. From left to right, negative 27 plus 12, that's negative 15. And then negative 15 plus 10 should equal negative 5, right? So I believe that's it. What I'm going to do, actually I already have done it on the Big Ideas Math website, is I'm going to give you guys the same kind of maintaining proficiency questions that they have in our book, textbook right before Chapter 8. I think there's only 9 or 10. I believe there's 10 questions. The first half, you have to do the graphs, just like we had on this previous board, where they'll give you a coordinate plane on the computer, and you just need to put the dots on there and make the line using the slope and the Y-intercept. And then there's 5 or 6 like this, where you have to plug in a number in the spot of a variable and then work it out. So I hope this is going to be one of the easiest assignments that we've had, or groups of questions that we've had in a while. Feel free to try it, and hopefully this will give you a nice little positive, easy warm-up that we can use as we start to proceed into Chapter 8 over the next couple of videos. All right, so thank you so much for watching, and I'll catch you guys in the next one.